How to beat robot singularity. Hello and welcome to my channel Robot Expertise Hub, where you will grasp the understanding how to program industrial robots. My name is Evgeny Dushkin and let's get started. What is a robot singularity? This is a phenomenon where a robot's Jacobi matrix becomes singular. What is a robot's Jacobi matrix? This is a mathematical structure which describes the relationship between the speeds of robot joints and linear and rotational speeds of robot's end effector, TCP. And in simple words, it means in some configurations a robot loses one or several dimensions of freedom, which makes it difficult or impossible to move a robot in certain directions. So I have prepared a little program and on our educational robots. So let's have a look on this program. Что мы тут будем делать? So on this video, a robot makes a motion in T1 mode for the singularity. And what will happen if I run this program on 100% speed in automatic mode? During the robot's certain past motions, robot velocity and acceleration monitored with these two variables. And once a robot exceeds these limits, the robot immediately stops and we can see an error message. We can see some messages here. Dynamic braking triggered, command velocity axis number 4 and overspeed axis number 4. 1200%. So we can prevent happening this by using one feature. This feature is CP type variable, and it might have several values. So using this variable we can just reduce the robot feed rates. Thus we can reduce the robot speeds and robot acceleration when the robot goes through the singularity motions. This variable might contain several values. So one of them is constant, which is default one. And we can use the several ones. Here is a var T1, it's specifically for T1 mode, and var all. So just apply this reduction for all robot operation modes. I will change this variable for var all value and we will see how it goes. So now we can see a video where a robot going through the singularity with 100% and it's not stopped anymore. This variable is very protected. That means you can't just switch it on or switch it off, whatever you want. So this reduction would be applied for robot motions till we change it back in custom.dot file. But note, this reduction and acceleration rates they applied for all motions for the potential singularities. That means in these cases robot speed and robot acceleration not sustainable anymore. That might be a crucial element for some robotic applications. Another way is to use Vris PTP feature. This feature is about changing the robot orientation during the linear motions. So if we apply the orientation joint, it is almost the same as we did with variable, like a usual case. And during the linear motions, a robot will change the tool orientation continuously, but not uniformly. So it's a very crucial objection that in some applications where robot have to maintain the tool orientation exactly as desired, so it's not a feature to use for this application.
Okay, let's select our program again. Firstly, I need to log into administrator again. And we'll change the movement parameters for the destination point. Here is orientation parameter, and we will choose the wrist PTP feature. And let's have a look how it goes. I will choose the monitoring of the variable to make sure we are definitely using joint orientation type. Firstly, it is a variable. Let's start. Yeah, and as the robot started to move in through the Singularity, our orientation type changed to the joint. And as we see, robot successfully passed it.
Let's summarize what we learned today. We have at least two features how to handle with robot Singularity. The first feature is to use CP type variable, and this variable might affect a robot's TCP speed. And second way is to use the wrist PTP feature, which might affect orientation of robot tool. That's everything about solving KUKA singularities for today. Type a like button if you find it useful and subscribe to make sure you won't miss the next videos.